Okay, so this is a solution to 2005 Higher Level of Physics, question 6. First question we're asked is to define angular velocity. I find this is easier with a formula, okay? So omega is theta over t, where omega is the angular velocity. Theta is the angle traced out, and that has to be in radians. And t is the time taken. The second question we're asked to do is to define centripetal force. I don't find the formula as intuitive here, so I'm just going to write the sentence. So centripetal force is the force acting on an object that keeps it moving in a circular path. And just to be absolutely clear, this is not centrifugal. The force acts towards the center of the circle. Okay, we should state Newton's laws of universal gravitation. For part 2 here, there is a formula as well. F is equal to, what is it, mv squared over r. I just don't find that as natural to explain as this sentence. You can absolutely explain it with the formula if you remember it, but that's not how my brain works. Okay, part 3, Newton's laws of gravitational attraction, or universal law of gravitation. Okay, so F is proportional to m1, m2 divided by r squared. So it's inversely proportional to r squared. F is the force of gravity. M1 is the mass of body 1. M2 is the mass of body 2. And r is the distance between the bodies. I know a lot of the books and the marking schemes use d for the distance. R is fine, as long as you explain what it is you're talking about. Okay, a satellite is in a circular orbit around the planet Saturn. Derive the relationship. Let's push this up a little bit. Derive the relationship between the period of the satellite. We give that the letter T. The mass of Saturn, give it a big capital M, and the radius of the orbit. Okay, well, what we definitely know is that the period, the time taken, is the distance travelled divided by the speed. Okay, so I have my period there, and I have a radius, which is great. I don't want speed though, I want mass. We know, right, that the force that keeps the satellite orbiting is gravity. I'm going to call that big M for the mass of Saturn times small m for the mass of the satellite. Okay, time divided by r squared and multiplied by g, the universal gravitational constant. I know the g normally goes first, sorry about that. This is also a centripetal force, okay, which means that it is going to be, I just did a second ago, mv squared over r. All right. So the reason I'm doing this is that because this force has mass and radius, and this force has mass, radius, and velocity. So if I can get velocity in terms of mass and radius, then I can substitute it back into the period. Okay. So what I'm going to do here, this is the gravitational force, which is the centripetal force. They're the same thing. They're the thing that moves a satellite in a circle. This small m is the mass of the satellite. So what I want to do is write this in terms of v squared. So v squared is the capital M times the small m times universal gravitational constant. I'm going to multiply both sides by this radius, or this radius squared is still beneath the line, and I've got to divide both sides by small m as well. Okay, that small m divides into that, it's gone. One of the ors on the bottom divides into that or, and it's also gone. So I get v squared is equal to g, putting the g back in its proper place at the start, capital M, which is the mass of the planet, divided by or. Okay, and that's v squared. I don't have a v squared in my period formula, so I'm going to make it, force it to be there by squaring everything. Okay. Okay, so my v squared is there now. It's 1 over v squared though, so I've got to do the inverse of this, or over gm. Alright, so you're still with me, there you are, good. T squared is equal to 4 pi squared or squared times or divided by gm. So that or is this or, and the gm is there. Remember, it's upside down because the v squared is beneath the line. And just to tidy it up, 4 pi squared or cubed over gm, where that's the mass of the planet. Okay, so hopefully that's nice and clear for you now. 6 minutes, I'll pause it there.